Kia ora, Year 11 and 12. In this video, I'm going to review how we find the line of intersection of two planes. I'm going to do that two different ways. First, by finding 2 points on the line, and secondly, by using the cross product. Now, if you're working out of our A-level textbook, this is done pretty thoroughly, as usual, on page 262 to 263. So this method here corresponds to what we call solution 1 in there. I'm not going to go through their solution 2 method, and this one is one that's not found in the book. And I think that's because we don't have to know the cross product at A level, but as you already know, it's extremely useful and it can speed us up. So I'm thinking by the end of this video, probably most of you are going to prefer this method, but this is still a nice, thorough one, especially if you're having a little moment of panic in the exam. So we're going to solve 2 problems. I'm going to do one really slowly first, and then one for you to try after that. So here's the first one. We want to show that these 2 planes intersect in a line, and then we're going to find the equation of that line. So here comes the bad drawing. And I want you to get 2 bits of loose paper, like we do in class, and just look at what can happen. So the 2 bits of paper can either be sitting on top of each other, right? In which case they are identical planes. So an example of that would be this. If we had x plus 2y plus z equals 1, and then we had 3x plus 6y, I'm seeing if I can multiply by 3. I still can, right? So those 2 planes are the same plane, right? So that's situation 1. So obviously there's not just a line of intersection. Any combination of points that satisfies that plane equation is where they intersect, right? So they're exactly the same thing. It's kind of trivial. Now the next one is a bit the same, which is where they're parallel, right? So take your 2 bits of paper and make 2 parallel planes. So here's the first one. So we might have 2x plus 2y plus z equals 1, and then we might have 3x plus 6y plus 3z is not equal to 3, so it's not like here, so let's just make that 72 or something odd. So the giveaway here is that if you look at the normal vectors for each plane, the normal vector for the first one is 1, 2, 1, and the normal vector for the second one is 3, 6, 3, which is equal to, it's a scalar multiple of the first, right? So all of this is pretty obvious, but it's just the way that we set up our thinking for when we're trying to figure out the line of intersection of 2 planes. So unless you've got one of those 2 situations, right, so the identical plane or the parallel planes, then if you take your 2 bits of paper, you'll find that there's going to be one plane like this and the other plane like this. And what we're looking for is, I'll change colour pen, we're looking for this line of intersection. And if you think about it, we can find that pretty easily by saying, hey, we can find a point here that's on that line of intersection, and we can find a point here. And then we just join the dots. So that's the first method that I'm going to look at. So working with the 2 equations that we had to start with, we had x plus 2y plus z is equal to 1, and 2x plus 3y minus 2z is equal to -2. So we can look for any 2 points that satisfy those equations. And the easiest way to do this is to say, hey, let's hope that somewhere on that line it goes through y equals 0. So that's going to get me my first point. And then I'm going to go, okay, let's hope that we have a point that goes through z equals 0. Now this method will usually work unless there is nowhere where y is 0. In which case you'll find an inconsistency. So don't freak out when that happens. Just go ahead and try using x equals 0. Okay, in this case it works out just fine, and you'll see that in a minute. So let's now substitute in y equals 0. And we're going to get a system of 2 equations and 2 unknowns, and we're going to solve those using year 10 methods, or even year 9, maybe year 8 for you guys. Right, so 2x, let's just get rid of that. So 2x minus 2z is equal to -2. Right, so it feels a bit weird. We've just arbitrarily said that y is 0, but it's going to work out fine. I'm going to multiply through equation 1 by 2, and that'll give me 2x plus 2z equals 2. 2x minus 2z equals -2. And I'm now going to subtract equation 1 subtract equation 2 from equation 1. So this is 1 and this is 2. That gives me 4z equals 4, or z equals 1. So I take that value and I chuck it back into one of those equations. So we'll put it back into this one here, and we get 2z plus 2 equals 2. Sorry, 2x plus 2 equals 2. So x must be equal to 0. And that's given us our first point, which is A. Just call it A. A is 0, 0, 1. So tedious, but not too bad. Now we're going to do the same thing to find our second point where z equals 0. Right, so we go back up here and we look at these two equations and we substitute in z is 0, giving us this: x plus 2y equals 1, 2x plus 3y equals negative 2. Now I'm going to pause the video and finish off this bit of working without you sitting through it because it's pretty boring. So just make sure you do this at home. You pause the video, do all the work, and check that you get what I get. Okay, well, hopefully you've chugged through that as well, and we've just come up with our second point, which has got x of negative 7, y of 4, and z set to 0. So we've got our 2 points. So going back to that terrible picture, here's my plane. The intersection line has got these 2 points on it. So to give the equation of that line, I just have to get the direction vector from A to B, or from B to A. It doesn't matter, but let's go from A to B. So the direction vector will be negative 7 minus 0, 4 minus 0, 0 minus 1, which gives me negative 7, 4, and negative 1. So the equation of the line can be written like this: R is equal to 0, 0, 1 plus lambda times negative 7, 4, and negative 1. So there we go. So that's the line of intersection. There's not a unique solution. So if you're doing these problems in the library at lunchtime with your mates and you get different answers, you're not necessarily both wrong. It will depend on how you've gone. Now the next one I'm going to do is the same question, but we're going to think about it a different way. So let's go right back to the start. We're looking at these 2 planes, right? And we've got this one here, and we often think about the normal vector to that plane. And the normal vector here is 1, 2, 1. And the normal vector for this one is 2, 3, and negative 2. So we know that in the plane, all of the points in the plane, sorry, let's try that again. The normal vector is perpendicular to that plane everywhere. That means that on the line of intersection, that line is perpendicular to this normal vector, but it's also perpendicular to this normal vector. And we have a cool way to find the vector that's perpendicular to both of those, and that's doing the cross product. Okay, so what we're going to do now is, instead of getting our direction vector here from manually finding these 2 points, we're going to get it very quickly by using the cross product. Okay, so what can we do to do that? So the direction vector for line R, or line L, will be perpendicular to both normals. Therefore, the direction vector is equal to this. Now, writing it out the usual way, we'll put our I, J, and K down here, and then we just chuck in the 2 normal vectors. And the normal vectors came from the equations, right? So it's going to be 1, 2, 1, 2, 3, negative 2. And remember, the signs of these go like this. So that direction vector is I times crisscross here, negative 4 minus 3, minus J, crisscross here, negative 2 minus these 2. What a big mess. Minus 2. Let's see if I can erase some of that. Oh, magic. Don't you wish you could do that in the exam? There you go. all cleaned up. And so lastly, it's going to be plus k (3) minus 4. And that gives me the direction vector of -7, 4, right? Be really careful here. You've got -4 here times -1, -1. Now look at that. That's exactly the direction vector we got from A to B, but we did that much, much more quickly. So now all we have to do is to find a point that is on the line, because we're going to write it like this. R is equal to some point plus lambda times -7 for -1. So we can go back and we'll do exactly what we did before. We're going to have x plus z equals 1, 2x minus 2z equals -2, letting y equals 0. So you're still going to have to do some of that work to get one point, but you don't have to be bothered getting both points and finding A, B manually. Okay, so it cuts out on some of the work. So I'm not going to do all that again, but that's what you'd have to do, and that gives us our point A, 0, 0, 1. Now this video is getting really, really long. What I'm going to do now is just give you one more example to do. I think it's worth doing it both ways. So there's the example. Pause the video and have a go. Practice doing your cross product. And now I'm going to put up the answer that I got. Okay, so my solution worked out to be this. Now that was by setting z is equal to 0. Let's see. Plus lambda times 1, -8, and -7. Okay, please leave me a comment. I'm sure you will if that's wrong, or if you've got a different version and you want it checked. You can either leave a comment in the video or you can email me. And my email, if you're watching this from somewhere else, is this. So there you go. Thanks for watching. I'll do some more vector revision ones over the next couple of weeks.